How are you? In this video, I'm going to cover the week number 5 tutorial session, and the start you're going to have is going to have an introduction for the chain drive at the beginning, which is repeating for the lecture video that we posted earlier, as well as we're going to have some for questions, and I'm going to make each question in an individual video. So we start first with the chain drive introduction. I'm not going to go through this one deeply. We explain what is the chain drive in general, okay, and how the power transmission is going to be done through this element. And the same thing, the chain, mainly the chain and the sprocket is going to make a change in the RPM and the uh, torque. So something similar to what we have in the case of the belt, but the chain is of course going to be stronger. It's made of metal, doesn't have any slipping, which is make it better. Some of the chain can go to a high speed, and in that case, going to need a special design, what we call the high speed sprockets. In general, they are noisy, and also they're going to require a continuous lubrication most of the time. And this is one of disadvantage we have for the chain. They are heavy, but as I told you, it's going to be more efficient than the belts. In general, most of the type is going to have a roller chain type. That's what we call a roller chain because, again, to see, maybe you hadn't went to this depth earlier in your real life, but if you're going to have a look to one of the chain, you're going to have rollers inside them. So actually, it's not going to be just direct friction between the metal pin and the chain itself. And sorry, and the sprocket teeth itself. So that's roller chain is classified by its pitch value. Again, the difference between one roller to another is called then the pitch value. This distance between corresponding part of the adjacent links. The pitch usually going to be illustrated as a distance between the centers of the adjustment pins themselves, and US standard for roller chain carries the size designation from 25 to 240. And you can check that in the tables 712 and 713. And these are the 712, 713. You can see that these are the chain numbers you are going to take for your design. And this is the equivalent ISO standard for them. And it will tell you what the pitch value in inches and what the average tensile strength we are going to have for these chains. That's for the metric roller chain sizes. Once again, you can see that the chain number is going to be listed here. Okay, and the pitch value is going to be given to you in inches and millimeter, but I think at this stage you already know that mainly, for example, like the half inch is going to be 12.7 millimeter, which is that means the 1 inch is going to 25.4. The braking strength is given in both pounds force and the kilonewton, and the alternate designation is going to be found in the metric one. So 60 is equal to 12B. And that's what we can see here. That 60 is given here as 12A. This will be most going to be the same. And we go, you can see that the ISO is going to have even more range than the sorry, the US roller type. So this one starts from 35 up to 240, and here we're going to have more by 2 smaller and 3 larger. This actually going to make you more flexible with your design. The chain drives are able to transmit a large tensile forces. Most common one is going to be roller chain. A typical roller chain drive setup, and some rollers are going to have a chain style. You can have either the single strand, double strand, and you can go up to 4 strand. You can see that we have the heavy series type of the roller chain. We have the double pitch value, which is going to be, you can see it's going to be doubled gap. And we have double pitch conveyor chain, which is going to have actually a thicker plates on the sides. That will make them actually more flexible to pitch value, but also it's going to make them more strong to take the stresses. The chain drive can connect to 2 parallel shafts, similar to the gears, suitable for the very long and short distances, and more compact, and power transmission efficiency can go up to 99%, which is much, much more than what we have in the case of the belts. No friction. That will be the most important thing. And that's what I told you last week about, okay, now it's also getting to the timing. It's not about only transmitting the motion. So that's what we have in the case of the timing chain in the engines. which is something well, actually, they made it later as a timing belts, which do the same effect. So these are once again the roller chains. You have the pins, we have the rulers inside them. Then we're going to have the pin link, sorry, the link plates on the side to connect between the different chains. This what we call about the pitch value is roller to roller distance, and the distance between the center of the teeth and the center of the roller during the contact is going to be half of the pitch value. That will be the RC value or the radius we're going to have for the Cordell value. So again, these are different types of the chains. You can see that actually various types, and one of the links usually going to be the spring clip one, where actually you can open the chain from this link, and you can remove some of the links and repeat it back to be shorter. These are once again the standard types, and one of the things that we must remember that the chain actually is not superior. That's when within the time and the operating conditions, these things may get to be expand, and that's why we may need to change the chains from time to time. The rating for are going to be for single strand chain, although that the multiple strand do increase the power capacity. They do not actually provide a direct multiple of single strand capacity. So that's where again to have it in one of the examples that actually there's a pre-tutorial example video that has been presented by Terry. You can find that in the Canvas page where actually, if you're going to have two strand, the factor is not going to be 2. It's going to be 1.7. Three strand factor is going to be 2.5, not 3. And the fourth strand factor is going to be 3.3, not 4. So again, the service factor is going to be applied in the design procedure, where we're going to actually design for the design power, which is going to be the actual power multiplied by the service factor. We learned about that and all the other application we had, like the gears, and for the belts as well. So we are going to have a design guideline for the chain drive. First, we start with the minimum teeth numbers should be 17, and usually this will be for the smaller driver sprocket, unless the operating is going to be at low speed, which is less than 10.47 radian per second. Then we can go with a little bit less numbers of teeth. The maximum speed ratio we can achieve with the chain drive is going to be 7. When I say 7, that means that the output RPM or omega is going to be 1/7 of the input. The center distance between the sprocket axis should be approximately 30 to 50 pitches. Okay, 30 to 50 times the pitch of the chain. That's mean the distance between center to center is going to be equal to 30 up to 50 single chains. The largest sprocket normally has no more than 120 teeth. Okay, if you get more than this number, that's when you have a wrong design. The preferred arrangement for the chain drive is going to be with the center line of the sprocket is going to be horizontal with a tight side on the top. Now, we're going to some of the table that's going to help us to choose the type of the chains. So usually the chain types can be mainly going to be the 40, the 60, and the 80. And here we're going to see actually how we can choose the chain and how we are going to get the number of the teeth. So you can see in this table, that's for the 40 type. And usually the 40 type is going to have 0.5 inches pitch value. You can see here that we are going to have the rotational speed of the small sprocket in revolution per minute. So for example, I'm going to have it as 900. So I will come to 900 and I'm going to locate that. And then I'm going to start to check for the input power that's been given to me, or the design power actually. So I will look for the design power in horsepower here in this table. And for example, my design power is going to be equal to 5 on the dot. So I will look here, I can find 5.02. So with the 5.02, I can simply locate what the number of the teeth we have. Now we have the pitch value, we have the number of the teeth, and we know the type was going to be type B. Okay, so again, I can get a different power. Sometimes we have to do some interpolation to do that. For example, I'm going to have as 800, so I will go between the 7 and 900. And then I get to have my power to be 6. So now I get to check what we are going to have at 800 here between the 5 and the 7. If I get to have it at 6, this will be okay. Then I will choose the number of the teeth. Again, this should sometimes going to be located between the 18 and 19. Usually we're going to take the rounding up. Now, another thing, actually you can choose either, and then the center to center distance will guide you through this process. And that's what the 60 type. You can see that at the same RPM or the 900 here, you're always going to have the power rating is going to be more than what we had in the case of the type 40. But the same procedure is going to be used to use this table. And again, for the type 80, oh, sorry, that's the pitch value is going to be 0.75 as well. And finally, for the type number 80, we're going to have that the 1 inch is going to be the pitch value. At the 800, you can see actually between both. You can check here the 800 RPM and check here the 800 RPM. So this one is 12.69 and this one is 27.4. So obviously we can tell that the number increasing means that the power rating is going to be higher. Okay, that's something we need to remember. And also for the type, we have a very important issue. When we're going to have the type is going to tell us here what is used for. So, how the method of the lubrication. So the type A is going to be manual or dribble lubrications, like just simply put a dribble on the chain, just start to drip the oil from time to time, or we can simply lubricate it from time to time. And we have the path or the disc lubrication for the type B, and we have the oil stream lubrication for the type C. That's something we have also to mention in our design steps or the summary. Now we come to the point number 6, which is going to be the chain length and the center distance. So the L value should be calculated by, first we're going to guess what will be the center distance value. Then we find the length value. Okay, these are the number of the teeth we have on, the number of teeth we have on each one of the sprockets. C is center, the C center distance. We can choose it anything between the 30 up to 50. And then after we finish with that, we can recalculate the value for the C, or is what we call the actual theoretical C value by using the equation 719. And I will come actually to the actual C value for our design. Again, as of the build drives, the chain drives can be selected from the data tables later. Now we coming to the next step, which is going to be the pitch diameter of the sprocket with the end teeth for the chain and the P pitch value. So when I get to get the value for the pitch, depending on the type of the gear we're going to choose. For example, for the N60 is going to be 12.7 millimeters, and then I get to divide it by the sine of 108 divided by the number of the teeth. I will get the diameter in millimeters. So I get to choose this value in inches, and I should get the same value, but it's going to be in inches because you can see that the denominator is going to be unitless. So we can find the D1 and the D2, which is smaller and the larger, and we move to the next step, which is going to be the minimum sprocket diameter and the minimum number of the teeth in the sprocket are going to be limited by the size of the shaft, of course. So I'm not going to choose something that's not going to fit on my shaft that I designed earlier. Now, again, as what we have in the case of the belt, we're going to have an arc of contact. So for the smallest sprocket, the value should be more than 120. If you're going to do your calculation for the theta one, and you found it is going to be less than 120, then you need to do your design once again by going to the step above, okay? Go to this step and select a new C value, okay? Anything within the range 30 to 50. And all different types of the of the chain. Usually, sorry, from this equation, if I again to choose a different p-value, definitely again to get a different diameters, which is going to be used here, and with the new c we're going to have. So by changing the theta 1, I always need to increase, decrease this value. So again, to have the theta 1 to be more than 120. If I get it less than 120, just redesign with a new guessing for the C, and then you're going to have a new pitch value to get the new diameters. Theta 1 plus theta 2 should be always 360. Now, we said once again that the lubrication requirement is going to be very important. Otherwise, that the thing itself will start to erode and break down. And method of lubrication, we said that we have 3 different types depending on the type of the chain that we're using. Usually, we're using the petroleum-based lubricating oil similar to the engine oil, again, to be recommended. Well, to be honest, back in the old days, something like 200 years ago, or yeah, 200 years ago, actually they were using the animal fat to do the lubrication for the chains. Now we're going to the way that we mentioned earlier, like the driven one, we can have the feeder lubricator and get to have the pipe with the multiple driving. So you can drive on the different sprockets to lubricate the chains. We can have it as the shallow pad lubricants, where we're going to have the oil level to be checked to a certain value. Part of the one of the sprockets is going to be immersed in the oil. So during the movement, the whole chain is going to be lubricated. We have the disc or the slider lubrication for the type B. Okay, that will be almost the same thing. And we have, you can see that we have the well gutter. So the thing's not going to be splashing all the ways. And that's your stream lubrication for the type C, which is something like we're going to have the 2 times the things going to be simply sprayed over the chain. Now, the roller chain life, the number of the teeth of the sprocket, the smaller the number of the teeth, the greater the shock loading is going to be. The chain speed, the greater the chain speed, the greater shock loading is going to be. So now, the number of the teeth on the sprocket and the chain speed, we should have the minimum number is going to cause the greater shock. The greater chain speed is going to have the greater shock. And poor lubrication will shorten the life of the roller due to the wear. And for the environment, usually dirty or the dusty conditions will tend to have an adverse effects on the roller chain. And that's actually what you have in your bicycle. So I will stop this video here, and I'm going to go back to the example 7.2, which is going to be about a gasoline engine. I have this driver driving a heavily loaded coal conveyor, and the NI value, which is the input omega, is going to be 94.23 radian per second. And we can calculate the RPM from that by multiply that by 30 divided by pi. And it's going to have 11.18 kilowatt. That's going to be divided by 0.75 to have the horsepower. And the range of the output omega is going to be anything between 24.0 to 25.13 radian per second. So we should design something that should have the output range to be within these 2 numbers. Find the design of the chain drive. Okay, so this will be covered in the next